Hi, this is Mike Lawless, and in this video I'll discuss support files in GastroPlus. This is tutorial 5.3.5. Support files should be stored in the same directory as the database file. This allows GastroPlus to associate the support files with the records in the database. Support files are ASCII text files, and they contain inputs for running simulations. And in this video I'll demonstrate using a solubility versus pH profile of miconazole. Support files can also contain experimental data. So this experimental data could be the plasma concentration time for a particular compound. And this allows one to visually compare the predictions of the simulation with the in vivo data. You can also use the in vivo data to fit parameters for the model. One can create a support file via a text editor. You can use Microsoft Excel to create this and then save it as a tab delimited text file. Or data can be input into GastroPlus directly, and that's what I'll show in this example video. Support files are loaded into GastroPlus via file load. If the support file exists, say a solubility versus pH profile for that particular record, then that will be opened when you perform this command. And as I mentioned earlier, I'm going to demonstrate using the solubility pH support file for miconazole. This slide lists the different types of support files supported in GastroPlus. Templates for the support files are shown in Appendix C of the GastroPlus user manual. In this particular tutorial, I'm going to use solubility versus pH data. The other two popular ones are, of course, using IV data from in vivo experiments or other dosage forms. Maybe this is an oral dosage form. This slide outlines the steps I'll perform in this tutorial. First, I'll start with the miconazole database. I'll copy the first drug record, load the pH or the solubility versus pH data, and save that as an SPD file. Then I'll enter the experimental PKa and log P data. I'll enter experimental solubility and calculate the native pH, and that'll be the same as the in vitro data I'm reading in. Then I'll perform a simulation. Now this first simulation just uses linear interpolation of the solubility versus pH curve. And as you'll see that this isn't the best way to perform the simulation. Then I'll repeat it using the built-in PKa model in GastroPlus. And then optimize the PKa and solubility factor to fit the solubility versus pH data a little bit better. And then finally compare the CP time profiles for the fit to the solubility data versus using just a linear interpolation. So here I've opened the miconazole database. It contains one record, miconazole. I've adjusted the dose to 500 milligrams as an immediate release tablet. And then I've also inputted a clearance value here of 0.65 liters per hour per kilogram. First thing I'm going to do is copy this drug record. The original record is based on ADMET predictor predictions for most of the properties, and we're going to change a few of those in the second record. So I go under database, copy drug record, and I'm going to call this miconazole EXP. And I'm also going to copy the notes with the record, copy support files with the record, which there aren't any, and unlock the new record. So when I do that, it automatically advances to the second record. Now I'm going to enter the data by hand. So I'll go under File, Load, and number 8 is Load Solubility versus pH data. First thing I'm going to do is specify the number of points, and I've got 4 data points. The default for the units is milligrams per milliliter. If this was incorrect, I could go under units and change to micrograms per milliliter. So those are the only two options there. If these don't fit your data, then you need to adjust your data to one of these inputs. If I double click on a point 00, it will simply delete that, and then I can just enter the value here. You can also click in a cell and then just hit the delete key to enter another value. I kind of like double clicking, so I'll go ahead and enter the other values here. 1.4, then we have a pH of 3.8 and 0.35 for the solubility, and then the next solubility is 7.3, and it has a very low solubility, 0.00103. So if we look at this data, raw data, you see you've got 3 points fairly close together, 2.53 and 3.8. Then you've got a fairly large separation to the next pH point, 7.3, and that also is concomitant with a very high decrease in the solubility. Now I'm simply going to click on the redraw button to draw a graph of the data, and then here's where you see the large drop in the solubility here. We can also graph that on a log plot, and it kind of transforms it. It looks linear when you plot it in the log space. So the next thing I'll do is simply save the file. So I go under File, Save As, and the program knows that the record is called miconazole space EXP, and it's going to create the appropriate name and extension for this. Now, we don't recommend changing the name of this because then it won't match the record name in the database, and therefore GastroPlus won't be able to match it up. Or if you save it in another or another directory, also GastroPlus won't know where it is. So we need to save it in the same directory and in the same using the same name as the record name. For this particular support file, we get a prompt that says the lowest pH in the table is 2.5, and so any other solubilities below that will just be set to the solubility at pH 2.5. Similarly, if you go to higher pH, it's going to use the highest pH in the table, which is 7.3. So we'll just go ahead and click yes, and that will save it. And then if we click OK here, we can go back into GastroPlus. And the important thing to note here is that in the comment or in this section up here in the GastroPlus interface, it notes that one of the support files is miconazole XPD, and it is a SPD file, which is the solubility profile data. Next, I'm going to change the pH, or excuse me, the pKa, the molecule, to 6.12. This is an experimental value. The prediction was very good, as you saw, very close to 6.12. Next, I'm going to change the log P to 5.34. Again, ADMET Predictor did a pretty good job of estimating the log P of this compound. And then finally, I'm going to enter the one of the experimental solubilities, and this will be the solubility at the lowest pH. Now, if I delete this and then double click here, it's going to generate the native pH. And the native pH is simply the pH of the solution at saturation for this particular compound. I don't want to update all the records, so I'm going to select no here, and I just want to generate the pH, the native pH for this one. So I'll click yes, and you'll see that that turns into 7.34. Okay, so now let's go into the simulation tab and start the simulation. When it starts, you get this simulation check dialog box, and the default is to use the built-in PKa-based solubility model. We're not going to use that just as an illustration. We're just going to use the raw data in the SPD file, and then click OK. Then it starts performing the simulation. What you note is that fraction absorbed is 100%, and this is much higher than the observed value. So now let's go back to the compound tab and click on the PKa table. When I do this, it by default displays the solubility versus pH profile for this particular compound, and it's using the data that we just input via the SPD file. So these are the points in the SPD file. Now, if we put this in the log scale, you'll see that this linear interpolation right around the pH 7 predicts very high solubilities, and this really isn't realistic, and you get very high solubilities up here simply because it's doing a linear extrapolation. And that's the reason that the fraction absorbed is so high for this compound. So this time, instead of when we start the simulation here, we're just going to use the default here. Click OK. And now you see that the fraction absorbed is about 60% on this. So that's a better way to perform the simulation. Now let's take a look at the PKa table again. And this is using the generated values. And you see here that any of these values below 4 by this plot are below the experimental value for the solubility. So what we can do is fit the model to the data. And what this does is adjust the pKa and the solubility. And so this is the better fit of the pKa and the solubility factor. We can switch back between these two fits, so we can plot the fit here. This is just using the data points in the model, and these are the fit points, and the fit points look a lot better. So I'm going to accept the fit, and then when I do, you'll notice that the pKa and the solubility now change. I'll go ahead and save that, and then we'll go back into the simulation tab and start another simulation. First, let's again load this data and reperform the simulation. You'll see that we get 100%. Now I'm going to go into the graph tab and create a new plot for this. So this brings up this plot, and I'm just going to modify this axis over here. I'm going to change the maximum to 2.5 and then change the increment to 0.5 so we can get a nice looking graph here that goes from 0 to 2.5. I'm also going to paste the simulation output, and then I'll copy this image to the clipboard and then paste it into PowerPoint. Okay, so now let's go back into the simulation tab and start a new one. This time we'll use the built-in PKa model, and this gives us oral bioavailability of about 75%. Again, I'll go into the graph tab and kind of reformat that plot, on the edit templates, change this again to 2.5, same as the other plot, and then the increment will be 0.5. Close that, and then again paste the simulation output, and then copy the image to the clipboard and then paste it into PowerPoint so that we can compare the two prediction values. Now let's take a look at these two simulation results side by side. So on the left-hand side, we have the linear interpretation of the solubility versus pH data. And you see here that the fraction absorbed is 100%. And so you get a higher peak concentration, closer to 2.5 here. And then on the right, we show the smooth interpolation of the fitted curve for the solubility versus pH data. And this results in a lower fraction absorbed, much closer to the observed value. And so this is really the preferred way, or the better way, to perform the simulation. So enter your solubility versus pH data and then fit it to the PKa model. This will adjust the pKa and the salt solubility factor to better fit the curve. And then when you perform the simulation, as the compound is making its way down the GI tract where the pH varies, it will use this to in the solubility calculation and give you a better fraction absorbed. Thank you for watching this video. If you have any questions, please send me an email at mlawless@simulation-plus.com. Thank you very much.